Assumptions for unpaired two samples t-test, or alternatively called independent t-test or unpaired t-test. Assumptions are certain criteria or conditions or characteristics of the data that have to be met before performing any specific statistical test. Each statistical test have a certain number of assumptions that have to be met before performing that specific statistical test. Violation of some of these assumptions can lead to invalid result or invalid interpretation of the data, or it can lead also incorrect conclusion. So before listing the assumptions for t-test, unpaired t-test, let's give a brief description of the student t-test. Student t-test is independent unpaired two sample t-test. It compares the means between two unrelated groups or unpaired groups. So there should be two variables. These two variables can be, one variable is independent variable, and this independent variable is categorical. It has only two groups in it. It is binomial, only two groups. Gender, such as the category of the gender, it can be either male or females. Undergraduate or graduate, those are two groups. The other variable is the dependent variable, and that dependent variable have to be continuous variable, such as blood pressure, weight, height, and so on. So to perform the student t-test, you need two groups. These two groups have in it a continuous data. The two sample t-test will determine if the two population means are equal or not. So the hypothesis will be generated, and the null hypothesis will state that the two population means are equal. Alternatively, the alternative hypothesis will state that the two population means are different, and then a p-value will be calculated and the statistical analysis will be performed and a value will be generated, and the null hypothesis will be rejected if the p-value is less than 0.05. So what are the assumptions for the test? There are 7 assumptions that are needed or required for unpaired t-test to produce a valid interpretation or analysis of the data. The first assumption is that the dependent variable have to be continuous. So the dependent variable is measured on a continuous scale that can be interval or ratio, such as revision time, exam marks, weight, height, salary, age, and so on. The second assumption states that the independent variable consists of two categorical groups, two separate groups, two independent categories. So the independent variable have two independent groups, such as the example of the gender, male or female, the employment status, employed or not employed, smoker, yes or no, and so on. The third assumptions for the t-test, unpaired t-test, is the independence of observation. What does that mean? That means that participants in one group differ from the second group. Basically, the participants in both groups are unrelated. So participants are assigned to one of the two groups and not to both. So participants are independent from each other within group or between groups. So the samples are unpaired. The fourth assumption is that no significant outliers. So what are outliers? Outliers are extreme low or high values or scores in the data that differ from the rest of the data. So how can we determine whether there is an outlier? By calculating the interquartile range, which is abbreviated as IQR, the z-score, the box plot. So this diagram shows a box plot to determine whether there is an outliers. The data are clustered between these boundaries or this range, the minimum range, the maximum range, and the line in the middle of the box is the median or the mean. And the star here is an outlier, which is an extreme score or value that is different from the rest of the data. So this graph box plot is a good tool to visually determine whether there is an outlier or not. The fifth assumption states that data are normally distributed. So the dependent variable is normally distributed in each group. To reiterate that both groups are normally distributed. So how can I check if the data are normally distributed? By plotting a histogram or box plot or QQ plot, or using several statistical tests that are available to check whether the data are normally distributed or not. The next graph here shows a histogram to visualize whether the data are normally distributed. And a curve is fitted into the data in a shape of a bell-shaped curve. The histogram will display whether the data are normally distributed or not. Another tool that can be used to determine whether the data are normally distributed or not is to use a box plot. And as shown here, if the two whiskers here are equal and the median is in the middle of the box, then the data most likely are normally distributed. Another way of checking normality when the sample size is less than 50 is to use a statistical test, such as Shapiro-Wilk test, to determine if the data are normally distributed or not. If the p-value is less than 0.05, then the data is not normally distributed. Here in this case, the data are normally distributed as the p-value is 0.2. Now, another way to check normality in addition to the histogram and box plot and statistical test is to use a QQ plot to check if the data is normally distributed. So draw a plot, and if the data points are aligned along the diagonal straight line, then the data is most likely are normally distributed. As shown here in this QQ plot, the diagonal line and this circle represent the scores or the value from each of the data. And all these small circles are aligned along the diagonal line, and this indicates that the data are normally distributed. If the assumption for normality is violated, then the t-test cannot be used, and an alternative test, which is the Mann-Whitney U test, can be used. This test is non-parametric test that is equivalent to two sample t-test. It doesn't require the assumption that the data is normally distributed. So if the data are not normally distributed, then this is the test to go for. Assumption 6 for unpaired t-test is that the homogeneity of the variances. What does the homogeneity of the variances means? It means that the two samples have equal variances. To determine if the variances for two independent or separate or unrelated or unpaired samples are equal, the first way is to use rule of thumb. If the ratio of the larger variance in one group to the smaller variance in the second group is less than 4, value of 4, then the variances are most likely equal. So then use the two sample t-test. Let's give an example here. Let's say that in one group the variance is equal to 24.5 and the second variance for the second group is 15.2. So if we divide the variance 1 to variance 2, a ratio of 1.6 is generated. So it is less than 4. Then this suggests that the variances between the two groups are approximately equal. This is one of the way of rule of thumb to determine whether there is homogeneity of the variances. A second way is statistical method by using the Levene's test for homogeneity of variances. The test will assess if the variances across two groups are equal, which means homogeneity of variances, by generating two hypotheses. The first null hypothesis states that the variances of the two groups are equal. The other hypothesis, which is the alternative hypothesis, will state that the variances of the two groups are not equal. Then if the p-value is less than 0.05, reject the null hypothesis. If the assumption for homogeneity of variances is violated, then use another test, which is the Welch t-test, which is a non-parametric version of the two sample t-test and does not require or presume that the assumption of the homogeneity of variances. The last assumptions that have to be met prior to performing unpaired t-test is the random sampling, which means that the samples are obtained randomly from population. So those are the 7 most important assumptions that have to be met to perform student t-test, unpaired student t-test. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovi, RStatistic, or Statistics, GraphPad, Prism, GPower, Python, and Mann. If you are a student or a researcher and you have a data, whether it is quantitative all qualitative and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovi, RStatistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.